In this video, we'll introduce ourselves to the Java programming language, and we're looking right here at the modules on Canvas, and you can see how I've broken it out here, video lectures. This getting started software installation is something that you should look at in order to install the software that you're going to need. Basically, you're going to be using Netbeans, which is an integrated development environment, and we're going to be using Java. The versions that we're using are not the newest versions, or at least the versions that I'm going to be using. You're welcome to install a later version if you'd like. These versions that we're installing, which is the Java version 8, JDK, and Netbeans 8.2, these are what we have installed in the labs, and this is what I've been using myself, and Dr. Azell, when he was teaching 331, was using. So these will be fine for you. And we've actually provided the install exe and the zip file, and there's instructions for how to do this. And I'll probably just step through it a little bit myself in a little bit. I had already shown you the class notes, and we're actually going to be starting with this first one, this intro to Java, and that's what we're going to be doing today. And also in the code examples are the samples from the textbook, the Daniel Liang 11th edition textbook, and we'll look at a couple of those as well, and we'll actually have a Netbeans project that will be all of these samples as well. So let's start with introducing ourselves to the Java programming language. A few things to say about Java. It tends to be a relatively simple programming language. Of course, more recently there have been even more simple programming languages to use. You're used to using Python, probably, and Python would probably be considered a simpler programming language to use than Java. But Java would be a simpler programming language to use than previous languages, such as C and C++, for example. Java is strictly an object-oriented language. Now, certainly there are object-oriented features in Python, but you don't have to do object orientation in Python. You cannot do anything in Java without creating a class. That's when we're starting to get into object orientation. We'll talk more about object orientation later. Java is distributed, and I think I'll go along with that, this notion of platform independent. Java was created kind of when the internet started to get big, and the idea was that you might have an application that has to run on a whole different variety of machines, not specifically for a particular CPU or operating system. And so Java was designed with that idea in mind. It's also interpreted, and many languages these days are interpreted. And what that means is that when you compile your Java source code, it's not creating the machine executable code of a particular CPU, but rather it's creating some intermediate level, lower level code. In Java's case, it's called bytecode, B-Y-T-E. You remember what a byte is, 8 bits. So bytecode, it consists of instructions that are 8 bits long, and we'll talk a little bit more about that. So when it's interpreted, that means that it's not just that the CPU is running machine instructions, but it's rather that there is some intermediate piece of software called the Java virtual machine, and we'll talk about that in a little bit, that is looking at this bytecode, and we'll talk about that in a little bit, and it's kind of instantaneously compiling instruction from instruction from instruction into the machine executable code so that the CPU can actually run it. This implies that it's not going to be quite as fast, although it does say down here it's fast, but it's not going to be quite as fast as some other languages like C or C++. However, it'll be faster than others. All things being equal, a program written in Java is probably going to run faster than a program written in Python. And we'll talk about some of the reasons for that as well. It was designed to be secure and safe. This was, again, at the time that the internet was taking off, and the issues of security really started to come to the fore much more urgently at that point than it had in previous times. And so part of the design features of Java, which were improvements over C and C++, which could sometimes be very unsafe. There are some things that you can do in C and in C++ that you cannot do in Java, strictly for that reason, in order to ensure greater security. Another thing about Java, although we're really not going to be dealing with that, is this notion of multi-threading. That's not unique to the Java programming language, but this notion that you might have a program that's made up of a bunch of independently running little processes, they call them threads, that are kind of taking place at the same time independently of each other, and Java supports that kind of thing. Now, we're going to be talking about object-oriented programming a lot this semester, and there are four principles that I want you to understand and to know and that you're going to learn about. These principles are encapsulation and data hiding and inheritance and polymorphism. Sometimes data hiding is considered to be part of encapsulation. I like to split these concepts out a little bit. So when I talk about encapsulation, the idea is that we're keeping the data and its related functionality together. And that's what a class is. A class is basically a description of a kind of an object that has certain attributes, certain pieces of data, and certain behaviors, certain kinds of functionality, and they're wrapped together and encapsulated in this class, which is way different from the way things used to be back in the olden days of programming. For example, with COBOL, when you would have a COBOL program, and that program, all of the data for that program would go in one section of the code, which was called the working storage section. And then all of the functionality of that program would go into another section, which was called the procedure division. And unless there was really good commenting going on and really good documentation, then you kind of didn't really have an idea of what data was intended for what kind of functionality. And that made code rather brittle and complicated and not very well structured. And one of the things that object orientation brings to the table is to give you that better structure. So that's the encapsulation part of it. In terms of data hiding, well, what it says here is we're providing an interface to the user. This is what the user can use. There are certain variables that maybe the user can use of a class. There are certain methods that it can call, and other things are hidden. Implementation details are hidden. So this is going to make things a little simpler in terms of programming tests, and it's also going to protect data from being used incorrectly or mistakenly or maliciously. So data hiding leads to simplicity, and it also helps with security. And then there's this notion of inheritance. The idea of inheritance is that we have categories and we have subcategories. And the subcategories may inherit properties of those categories and may have their own specific properties as well. Object orientation, one of the great advantages of object orientation was the ability to reuse existing code and to specialize it if we need to specialize it. So a class is this nice unit of functionality and data that can be used over and over and over again for a lot of different purposes and a lot of different programs. And maybe I want to make something that's a specialized version of that class, and I can create a subclass of it, and that's what inheritance is all about. And tied in with that is this notion of polymorphism, the ability for the same request, the same call of a function, if you will, to be interpreted by objects of different types in different ways. So when we get to the latter part of the semester, the second half of the semester at any rate, we'll be diving into inheritance and polymorphism. This notion of classes and instances is going to be very important. A class is a category of things, and an instance is one of those things. So if we had a class called person, each and every one of us is an instance of that particular class. If we had a subclass of person called faculty, I might be an instance of that, and another subclass of person called student, and you might be an instance of that. I would not be an instance of student, at least not now. I'm not taking any classes right now. And you are not an instance of faculty, but we are both instances of person. And we'll be talking more about that. So this diagram here shows essentially what the process is of writing Java programs. First of all, you're going to write your source code. Now, we're going to be using an integrated development environment called Netbeans to do that, but you could do it in Notepad if you wanted to. Some people do. When you write your program, that program is going to be a class. Remember, everything is object-oriented in Java, unlike in Python. In Python, you would have modules, and maybe you would have classes, but you did not have to have classes. In Java, you do have to have classes. You can't do anything without creating a class. So when you write your source code, you're going to create a class, you're going to create methods for that class, you're going to create variables for that class, And you're going to write this code in Java. You're going to do it in some kind of an editor. As I said, we'll be using Netbeans. And you'll save it, and the file name, it will be something with a file extension .java, something.java. And then the file gets compiled. So this is the source code that you wrote. You typed your stuff in and all your instructions, just like you type in Python. And then you compile it. And when you compile it, well, part of the compilation process is to check and see if the code that you wrote is obeying the grammatical rules, the syntax rules of the language. Same thing was true in Python, and I'll bet you had your share of syntax errors when you were doing some Python coding, and you're going to have your share of syntax errors as well when you're doing your Java coding. So what happens? If it doesn't syntax okay, what do? You got to go back and do some changes to your code. And then it's saved and then it's compiled again. And then you go back and do some changes until all the compilation takes place successfully. And once the compilation takes place successfully, then another file is going to be created. And this file is the file that contains the bytecode, BYTE code, and its file extension name is going to be .class. Notice what the program is that does the compilation. Java C is the name of the program that does the compilation. I'll show it to you in the Windows folder in a little bit. So let's assume that you compiled okay, and now you have this bytecode, and now you're going to be able to run it. And when you run it, you're executing it using another program called java.exe. And this program is often called the virtual machine, the Java virtual machine. You can think of it as emulating a CPU. It's not a CPU. The CPU is a piece of hardware. And we're not talking about bytecode is not machine instruction set, which is the instruction set that's specific to a particular CPU. There's a lot of different semiconductor companies. Intel is a very prominent one, and probably you're using an Intel chip. Samsung is another one, and there's a ton of them. Each manufactured CPU has its own instruction set. So we don't have to worry about that because we're creating bytecode, and no matter what computer we're running that bytecode on, the Java virtual machine for that particular computer is able to interpret the bytecode and make it run on that particular computer. This is one of the reasons it's considered to be platform independent and more of a distributed kind of thing, Java, than some other languages. Like, for example, with C, if I compile my program in C, if I compile it on an Intel chip, then it'll only run on an Intel chip. If I wanted it to run on another kind of chip, I'd have to compile it on that chip. You don't have to do that with Java. So, assuming that the syntax is okay, you got your bytecode, and then you're running it, and then, of course, then the question is, are there bugs in it? And chances are the answer to that is going to be yes. So, therefore, the logic will not be okay, and then you got to go ahead and go through that same process again. And maybe in trying to fix that bug, you might have introduced another syntax error. So you're going to have to do that again. And eventually you've fixed that particular bug, but maybe there's another bug. And then that whole process takes place over and over and over again. And then finally, when you're done, that's when you're ready to turn your program into me. Not until then. That's going to be your life for the rest of this semester. So let's talk a little bit now about what are the pieces of a Java program. And I've listed a few words here: comments, reserved words, modifiers, statements, blocks, classes, methods, packages, etc. Comments, that's the documentation. If you were writing in Python, your comment would begin with a pound sign. In Java, it's going to begin with a // 2 forward slashes, or you can have multi-line comments, which begins with a /* and then ends with an */. This is just for the purpose of someone being able to read your source code as explanatory kind of stuff, and the compiler completely ignores this. Then there's the reserved words. These are keywords of the language, such as the word if, or the word while for a while loop, or the word for a for loop. Some of those words will be familiar to you from Python as well. So there are some keywords of the language, and these are giving specific kinds of instructions to the Java virtual machine. And then there are what are called modifiers. And we'll talk a little bit about these modifiers. The two main kind of modifiers that we're going to be talking about is a static versus instance static modifier. And we'll talk about that later on, not that much at the early parts of the semester. And then also visibility modifiers, private, public, things of that nature. Those were some of the things that we do in order to implement data hiding, which I was talking about before. And then there are statements. These are instructions that tell the CPU what to do. I really should say tell the Java virtual machine what to do. And those statements can be grouped in blocks. And those blocks are going to be surrounded by these curly braces. You're going to see a lot of curly braces in your code. So a block of code is embedded in curly braces. And then there's this notion of classes, which I talked about before, and the notion of methods, which are the behaviors that the class does. You have heard the term function. I know you use the term method in Python as well, but not all functions are methods. Some functions have nothing to do with object orientation. When a function is associated with a class, that's when it becomes a method. So the behavior of a class is implemented through methods. And if you have a class that is actually a program, and by the way, not all classes are programs where you actually call the program, run the program. Some classes are just components that a program will use. We'll talk more about that stuff later on as well. But if you have a class that is a program, an application, that class is going to have a method called main. And that's where we're really going to be starting. When we do our thing, at least in the beginning phases, we're going to do everything in a main method. And then there's this notion of having packages, which are groups of related classes. And we'll be seeing a lot of these groups of related classes. This is not a concept that is unique to Java either. You have the same kind of idea taking place in Python as well, or in many, many other languages. Sometimes they use the word namespace instead of the word package. But that's basically what it's about, a group of related classes. So here we have our first example from the textbook. Just a hello world kind of example. And let's look at some of these pieces here. Here is the Java code right here. Notice the curly braces. First of all, what do we have? We got comments. And if we want to comment a single line or even part of a line, we can put a slash slash. Or if we wanted to do multiple lines, we can begin with a slash asterisk, and then everything that comes after the slash asterisk will be ignored by the compiler until it gets to an asterisk slash. So those are comments. I definitely am going to expect you to comment your code because you want to be able to explain to me what you're doing in your code. Here is the package of a class. So classes will be in packages. And here's the package. In the textbook examples, there are packages for each chapter of the textbook. So there's going to be a chapter 1 package and a chapter 2 package and a chapter 3 package. I'll be showing you all that stuff in a little bit. So at the top, the first instruction in your code will be the name of the package that this class belongs to. All of these are examples of reserved words in the language. The word package is a reserved word. If it's a reserved word, I can't have a variable of that name. I can't have a variable called package, at least called package lowercase p-a-c-k-a-g-e. Uppercase I can. And that brings us to something as well. Java is a case-sensitive language. Not all languages are case-sensitive. Python was also a case-sensitive language as well. But some languages are not. Visual Basic is not, for example. At least you can configure it so it's not. Public and class and static and void, all of these are reserved words, are keywords of the language. There's an appendix at the back of your book that shows all of the keywords of the language. That appendix, by the way, is Appendix A, and in my version of the textbook is on page 1157. These particular keywords are modifiers. Public is indicating a visibility capability. So there's public and there's private and there's protected, and we'll be talking about those later on. Another modifier is static. There is a distinction between methods that are specific to instances versus methods that are generic for the whole class. And static indicates that this would be a method, or for that matter, a variable. You can have member variables as well that are static, that is for the class as a whole. We'll be making those distinctions as well later on in the semester. This was a statement. Notice it ended with a semicolon. All statements end in semicolons in Java, unlike in Python. So there's going to be some getting used to flipping from one syntax to another. As a matter of fact, when I code in Java a lot, and then I start coding in Python, I often accidentally put a semicolon after my statement, and then I have a syntax error in Python. Or sometimes if I code in Python for a long time and then I'm switching to Java, I forget to put the semicolon, and then I have to do that and make a correction. So statements will always end with a Python. This system.out.println will break that out in a little while. This is basically printing something to the console window, much the same as your print function that you would have called in Python. Now, as I said, statements can be arranged in blocks, and those blocks can be embedded within one another. So here we have a block that has all the code for this class that we call welcome. And within that block, here's a method that we call main, and I'll talk about that later. And main's method also has a block. So we're going to wind up having blocks within blocks within blocks. Notice the indentation here. That's going to be very important for maintaining the readability and understandability of your code, proper indentation, among other conventions that we'll talk about later. Java does not force you to indent your code. For that matter, this entire program could have been on one line of code if I wanted to, and it would have run just fine. I wouldn't be able to understand it, but it would run just fine. There's another difference between Java and Python. In Python, you have to indent. Otherwise, you're going to get syntax errors. In Java, you don't indent, you're not going to have syntax errors. As a matter of fact, the code might run just fine. It won't be readable, but it will run just fine. And then here's this notion of a class. In this application, we are creating a class called welcome. So welcome is a class. We created it. We're declaring it. This is a declaration of a class right here taking place. And we're also using a couple classes. We're using a class called string, and you're familiar with strings. And we'll look more at strings as well. And then we're using another class called system. And system has a variable called out, and as we'll see, that out is a member of another class, an instance of another class. And we'll talk about those kinds of things as we move forward. A class is a complex data structure, and it has both data and it has behaviors. And of course, we're going to be doing a lot of that. So the behavior of a class is done by a method. What's a method? It's a named block of statements. So here's the name of it, called main. And here's the block. It has all the statements in it. And it can take arguments. In this case, it's taking an argument that is an array of strings. So this open bracket, close bracket is indicating an array in much the same way that in Python it indicated a list. Arrays are similar to lists, but there are differences, and we'll talk about that later. And all Java applications have to have a main method, which is the entry point to the program. Not all Java classes. In fact, the vast, vast majority of Java classes are not applications. They're objects. They're intended to be objects that are used in an application. String is not an application. String is not a program. It's a kind of an object that you use. System is not a program. It's a kind of an object that you use. Now, when we want to build and run Java applications, we could do everything from the command line if we wanted to. And some people like doing that. And there are options for doing that. I obviously prefer to use an IDE because it's simpler. It has a GUI interface, has menus for doing certain things. There's some graphical debugging tools. Very, very useful environment. Netbeans is not the only Java integrated development environment that there is. There's another one that might even be a little more popular in the professional world called Eclipse. With Eclipse, you can do more than what you can do with Netbeans. Netbeans is probably simpler to use. And so we're going to be using Netbeans as our integrated development environment. At least I am. And so what is Netbeans? Integrated development environment. Visual Studio is another integrated development environment. You had a very, very simple kind of trivial integrated development called IDLE that we used, IDLE. Had a text editor, you can run things, did some syntax checking for you. Had a very, very crude debugger that was probably not very fun to use, and if you used it at all. Netbeans, I think, is much better than that environment. And when you move on to CIS 484, which I assume will be done in the SQL Server environment with the Microsoft environment, you'll be using Visual Studio. Back several years ago, when we taught CIS 221, we taught it in Visual Basic, and so students use Visual Studio for that as well. And you can maintain a project. There's color coding and a smart editor, tools for building things, compiling, execution, debugging, all that stuff is wrapped in the IDE. And we will sometimes have projects that are going to have multiple classes, multiple source files, and maybe even multiple packages with classes within it. So this is going to be something that's going to be important to be able to manage these projects. Netbeans gives us a way of doing that. Here's what a Netbeans environment might look like. A bunch of different windows. This is the projects window. This, by the way, this Liang 11E samples, this is something that I'm providing for you. I'll show you that in a little bit. I'm providing you the Liang 11E samples, which has all of the chapters of the Liang textbook with all of the examples. Now, obviously, we're not going to be going through all of these. There's a lot of stuff in that textbook that we're not going to have time to cover. But there's a rich variety of examples and cool little snippets that you can learn from if you chose to take the time to do that. There's this notion of a navigator window. This is enabling us to, when we're looking at a particular class, we can see all of the members of this class. In this particular case, there's only one member of the class, which is the main method. But you know, if you were to look at them in the navigator window of other classes, you might see a lot more than that. There are a variety of windows for output, and there's also windows that help us to do debugging. And we're actually looking at what's called the call stack, and you can see where there's green, how this is green here. We're basically, this program is actually executing right now. It just completed this statement, welcome to Java. That's why you can see it down here in the output. And it's right before the method is about to end, and we're seeing the call stack. We'll talk about the call stack. We'll talk about local variables. We'll talk about stacks and heaps and things of that nature as we move forward this semester. And as I said, we're going to be making use of these samples. So I think what I'm going to do next is I'm going to show you how we can do that. So as I said, you have these instructions for how to install Java and Netbeans on your computer. And if you do the installation correctly, and then when you run Netbeans, you will see something that looks like this. So this is the beginning point of our Netbeans project. Here on the left here, I've got this projects tab, and at this point I don't have any projects open. So let's actually make use of that very first project, which is the Liang 11E samples. So here I am back on Canvas. And if I look at code examples, here is the Liang 11E samples zip file. I'm going to go ahead and download that. And within it, there's a folder. So I'm just going to copy this folder from the zip file, and I'm going to put it into a folder. And this is where I'm going to keep my Liang examples. I've got a little temporary folder here on my desktop. You decide where you want to put yours. And we're going to use this particular project. We're going to use it a lot throughout the semester. I'm going to be going through a lot of these examples throughout the semester. So maybe go ahead and paste it. So once it's pasted in, if I double click on this folder, you see a bunch of subfolders, one of which is SRC. This is the source folder. If I double click on that, here we have the folders of all of the packages of this particular Netbeans project. And so again, what was a package? A package was a collection of related classes. And if I go to chapter 1, for example, you can see that here are all of the Java files that are part of this package. These files are Java files. They have a .java as the file extension. You might not see that when you're looking in your folder. However, there's a way that you can see file extensions in the File Explorer. Let me go to my view. And in my view, you'll see that there's a checkbox here. So I go to view at the top here. I see there's a checkbox, file name extensions. If I check that, now you can see that each and every one of these are files that have .java on the end of it. And the same will be true in chapter 2 as well. So in all of these cases, all of these Java files contain classes. Some of those classes might be applications, but not all of them will be. So now if I go back into Netbeans and I want to use that particular project now, I'll do a file and I'll say open project, and I'll navigate my way to that folder. And notice that in temp, the folder that is under temp has a little funny little coffee symbol. That's the Java. That's what Java, I guess, was named after, coffee. I guess coders have a reputation for drinking a lot of coffee. So I'm going to open this. And when I open it, you'll notice here's my source packages. And there are all of the packages. Chapter 1, Chapter 10, Chapter 11, well, but there's Chapter 2 as well, you can see. Okay. I open up Chapter 1, and here was that welcome. Let's pull that one up. There's the welcome.java. If I want to make this font bigger, I can go to the Tools menu and pull up Options. And in Fonts and Colors, here's the font that says monospace 13. Let me make it a little bit bigger, maybe make it monospace 20 instead. And if I click OK to that, and now it's a little bit bigger. So this is the program that we were just looking at. If I want to run it, I'll right click on here, and I'll go ahead and run it. And you'll notice that the output says, welcome to Java. Maybe I want to debug it. So what I'm going to do is I'm going to put a breakpoint here, right at this line right here, which has the close brace that's closing off the block of the main method. Isn't this nice how when I select a close brace, it'll show what the matching open brace is? That's another thing that is an advantage of using an integrated development environment. So let me put a breakpoint here. And this time, rather than running it, I'm right-clicking. I could do this from the top as well. I'm right-clicking. I'm going to go ahead and debug it. And it came out, and if I look at the output, it does say welcome to Java there. But you'll also notice that it's showing variables data, including this args, which is this argument that has been passed to the main method, which is an array of strings. We'll talk about that later on. So basically, it's stopped right here. I'm not seeing the call stack down here, but I can see it if I want to. If I go to Window, Debugging, Call Stack, and I see it down there. Let me move it down to here instead. Put it right there. And there's the call stack showing that we are in the main method right now. And then when I continue, it'll go ahead and complete. So that was our first foray into using Netbeans and into working with the examples from the textbook. I do want to show you a few other things before we complete this video. I showed you earlier this slide, which was indicating the programs that are being run as we compile and execute our code. And it might be useful to see where those programs are located on your machine. I'm using a Windows machine, so it might be different on a Mac, probably will be. But let me show you where you can typically find them if you're running a Windows machine. So here I am in File Explorer in the C drive, the root of the C drive on Windows. Typically where you're going to find the Java stuff, unless you had installed it differently from what the default is in the program files. Let me double click in there. And you'll see a subfolder called Java. I'm going to double click in that. And within that subfolder, you're going to see folders where the Java stuff is installed. Now, you'll notice I have two different Java folders installed. One is called JDK and the other is JRE. JRE is Java Runtime Environment. That does not contain any development support kind of things. That's just if I happen to have a program that has to run on my computer that's a Java program, that's what I need. I need the JRE. Only when I'm doing development work do I need the JDK. If I go into the JDK folder, and I'll double click on this one, and yours might not be exactly the same. Obviously, this is 1.8.0-141, so it's part of Java 8, but it's a particular release of Java 8. Yours is probably going to be different. And as I said before, right now it's Java 14 is where we're at. Now, if you're going to install Java 14, then you have to install a newer version of Netbeans as well. So that's why we're providing for you on Canvas the stuff that we're just using in the lab. So if I go into this folder, and you'll notice there's some subfolders under it, and one of those subfolders is bin. This is where our binary code is, our executables are. And there's a whole bunch of files there, some of which have these little coffee symbols, and these are actually programs that are running. So here's java.exe. Java.exe is the virtual machine. That's the thing that's reading your bytecode that you would have created if it compiled successfully and is interpreting it and is basically translating it into the instructions of the machine instruction set, one instruction at a time, as I've said before. So that's java.exe. There is also something called javac.exe. This one right here. This is the Java compiler. That's the thing that actually will do the syntax checking of your code. And another very important one is this JDB. That's the Java debugger. So we could be just running these from the command prompt in Windows if we wanted to, but we don't have to because Netbeans is doing it for us. And we can see that Netbeans is doing it for us because if I want to right click, I want to look at the properties of this particular project. I'm going to right click on this project. I'm going to look at the properties. And if I look at the libraries and what library I'm using the Java 1.8. So we have options when we use Netbeans to decide which version of Java we want to be using as well. And there's all kinds of other things that you can do with these project properties as well. I won't get into that right now. There will come a time when we're going to want to add some libraries, some jar files. Jar stands for Java Archive File. But we're not going to worry about that right now. So I think that's all I wanted to talk about in this video. And the next one, we're going to start working with the primitives of the Java language and maybe do something that's a little bit more than just hello world.